Hello everyone, Jorge Arteiro here from Cloud Native Advocacy Team at Microsoft. I'm so glad to be here on day 3 of .NET Conf. So many amazing content happened so far, and we're going to deep dive. I'm going to share here my screen on running .NET Aspire on local Kubernetes cluster. To have agenda, how can we use local Kubernetes cluster for development compared with Azure Kubernetes Service? Also, I'm going to show my local development environment. I hope you are excited and all the tools that I'm using, to build this demo and to do development with .NET Aspire, and now .NET Aspire 9, and also with Kubernetes. Then we have a few demos. I don't have too many slides. We'll be pretty much hands-on, and we're going to deep dive on the content and on the demos, looking how to create a cluster using Kind. That's a project inside the Kubernetes project. You can create a lightweight cluster on your machine, and you can see how can we generate the Kubernetes manifest files, the YAML files, to deploy on Kubernetes. That's the only way that you can deploy on Kubernetes. And also, how can we deploy to this local cluster? And then have a surprise, you get to debug your local cluster. We're going to use Visual Studio Code. This project called MiroD is an open source project. And at the end, let's see if we have time for some extras and some bonus. Let's get started. So what that means to have a local Kubernetes cluster. We have a few options here. When you talk about local clusters, could be a Docker desktop. We're going to use Docker desktop anyway. I'm on Windows. We're going to use Docker desktop, but we can use the standard Kubernetes cluster coming on Docker desktop. Yes, you can. Or you can create another one. I'm going to use Kind to create those clusters. You can have multiple clusters as well. You could be using something like a Ratio Desktop, OK3D, OK3S, or MicroK8s. I'm going to use Kind today. And before we start, keep in mind, for you to talk with Kubernetes, you need to understand those main resource types on Kubernetes. The first thing is isolation, namespace. That's how you isolate your workload inside the Kubernetes cluster. And another one is deployment. Deployment is deploy your application, let's say your front end, and you want to manage the replicas. How many replicas? You want to manage the orchestration of those replicas. And each one of those replicas is what we call pods. We don't call containers, we call pods, where you can have multiple containers running on these pods. And the deployment is managed using these replica sets to manage those replicas. Then when you create a deployment, the deployment creates replica sets, and that replica set keeps watching all the pods, all the replicas. If one replicas go down, they create another one, make sure that they have a balance across the nodes. If that's the case, the configuration asks for that. And the service is one very important, because if you want to expose, if you want to like a load balancer in front of a workload, let's say you have 5 replicas, you want a load balance between those, you can have a service, is an internal load balance on Kubernetes. And that's how you do. You can have a cluster IP for internal load balance. You can have node ports, and you're going to use node ports on this demo today. And also volumes, then you can have attached volumes on your pods to attach like persistent storage, and you're going to use that as well. And not going to be in detail in all of those things, but keep in mind you can have things like you're going to use config maps when they have your application configuration, also like things like secrets and so on. Then for us to talk with a cluster, we need a cluster. We need that kind that I was talking about. How can we create that cluster? How that compares with our Azure Kubernetes Service cluster that we see on the screen. On Azure, we have all those components prepared for you. You don't care about the control plane. You pretty much only talk with this API server, and you have access to a bunch of nodes. Those are your virtual machines that we pretty much scale up and down. There is outscalers available. There is now AKS automatic that you don't even care about those nodes. But that's how we spread the workload across multiple machines, multiple zones as well on Azure. And how that works to create a cluster, a local cluster. And don't forget, the demo today will be about .NET Aspire. .NET Aspire is pretty much bringing like Docker Compose, all that orchestration for you for your .NET applications now. All that integrations that used to call components, now we call integrations. I just create a project with front-end API, and you're going to use that deployment. What that deployment means, we're going to use a tool called Aspirate, and we're also going to use kubectl. That's the command line tool that we use to talk with the Kubernetes API server. And also see how can we get this developed dashboard and now not just running locally. Can I have a dashboard running on my local Kubernetes cluster that I don't have to be restarting all the time? Yes, you can. Let's see how that works. So the demos are, let's create a cluster, let's generate the manifest files, deploy the cluster, and then let's try to debug. Please clone my repository on GitHub, Jorge Arteiro moves-store. It's a new demo that I just created for Ignite and for KubeCon, and we're going to use today as well. So if you haven't subscribed yet, the Azure Kubernetes Service team with the Debuggers team create this channel called the AKS community. There's a lot of content there. If you want to follow Kubernetes, just go for the AKS community on YouTube and follow us. So let's get started with my GitHub Move store. We have front-end, API service, and our step host project with the service defaults. That's the basic of starter .NET Aspire 9. I'm using .NET Aspire 9 with .NET 9 as well. Then if you look at this application is running here. That's web front ends. And we have movies where once you click here, we're going to call the API and you're going to get the movie. Another time that you advance a little bit on the movie, you're going to get another part of the video and doing all the streaming on the API. And you can see the API running here. And also you can do one and the API is working. And this all being deployed even with domains and everything on Azure Kubernetes Service. And as you can see, I have the 3 pods, and I also have storage. In this case, I'm using persistent storage, ephemeral disk with replicas. There's a new service that you can have on Azure Kubernetes Service. But I want to run this on my local Kubernetes cluster. How can I do it? Yeah, we're going to be using this tool that's called Helm. You can download, that's maintained by Microsoft, part of Microsoft, and is open source. And as you can see, my application have these 3 components, a dashboard, they're all running on Azure. But I don't want to run on Azure. I want to create my cluster. And how can I do it? I put some instructions here on the repository. There is a command line to kind, and you can create clusters, kind clusters. And for that, don't forget that everything that we do in .NET Aspire, we need Docker Desktop. How kind works? Kind is going, you can use this command line that you can create the clusters via command line. And in my case, on my VS Code or in my application here, I have my movie store here or my components. What I did is I create a configuration file for .NET Config here, where I'm going to expose some ports because we're using WSL. Don't forget that I'm using VS Code here, but I'm using Windows Subsystem for Linux. I'm running complete on Linux. And to create a cluster, I need this configuration file where I'm saying I want just a single node that will be my control plane. And I can also deploy my application that. And I want to open all those ports because I need the ports for my front end, API, dashboard, and OpenTelemetry as well. Then locally, on my machine, localhost, I'm going to be using those ports, 89.1, 2, 3, and 4. And they're going to be pointing for a node port of the cluster that you're going to create. So after this done, we can just use this command. We can create a cluster. We're going to call kind.NET conf. And quickly, they're going to prepare the nodes. You can come here on Docker Desktop, and you're going to see control plane being created and also the ports being mapped on my local machine to the cluster. And the cluster is running inside the container. That's how kind works. They create one container where your cluster is inside that container. And there you go. We have one node. We have one container for each node. For that specific node, I map all those port numbers. So voila, we are back in the clusters now created. And also the get context already there means that we can have access in get nodes and see how many nodes we have. We have one single node. And now let's deploy. So the first thing I want to do is that's my WSL location where my kubeconfig file is. I want to import this on my headland, and I choose that here. That's it. You can select the config file. I just need this new one, .NET Conf. And voila, we have this. You can access the cluster from here, and you can see there is nothing at the moment running there. Let's learn how we can generate now the Kubernetes manifests using a tool called Aspirate. We're going to use this tool, Aspirate, based on installation. They can just install .NET install pre-release. We have to initialize the repository, and then we can generate the manifest files. We're going to use Customize, not Helm today. If you want to see how I did with Helm as well, you can watch this other video, and also an introduction that I did on .NET Aspire. But this one was on Aspire Day. There's a lot of information here. And also we're going to learn a little bit about debugging with MiroD. There's another video here on the Azure tab. Also, please subscribe both channels. On Aspire 8, once we have this tool installed inside the app host, and we can run Aspirate init, they're going to ask a few questions. Do you know override the existing configuration? I'm going to say yes. I'm going to do again. And then I'm not going to use any container hash configuration. You can do it yourself. Or Azure Container Hash, for example, I'm not going to do it. Then I'm going to set a prefix for all the images being created. I'm going to use my Docker Hub. Then all the images will be created if Georgia / the name of each one of the components, like front-end, the API. And then I'm not going to create any template directory in this case, and the initialization is done. There is an aspirate.json file that was being created, being generated. The next phase is we want to build the application, but we can also do this all together with generate. Build is going to build the Docker image, the container image using the Docker desktop, and generate is going to do the whole thing. I'm not set anything because the default is using customize. Do the previews? No, I want to do again. I'm going to define one password, just my name, George, could be anything, just how they handle secrets. They're generating now, and they ask you which components you want to do. I'm going to do for both API and web front-end as well. And now they ask if you want to deploy the dashboard. Yes, we're going to deploy the dashboard. I'm going to build the Docker image. You can follow this on Docker desktop. They're using .NET Publish to create the Docker image. They're going to the API service and also for the web front-end. We go on images on Docker desktop. You can see 5 seconds ago, the images are being created with the prefix. And once both are created, they ask you how you want to generate the Kubernetes manifest. Remember the deployment and pods? Or you say, ours put the Docker image, even if it's already there on the cluster, ours. And they ask if you want to handle a namespace. Yes, I want to create a namespace called move store. Then we're separating by the namespace. And I'm going to create a top-level Kubernetes customized manifest, yes. And that's all generated inside this Aspirate output folder. If you go there and inside the host project, then we have now output. Is that enough to deploy? If that's enough, you can just go and apply. I prefer, there are 2 ways to do it. You can do using after generate, you can use Aspirate to apply. You can do Aspirate apply, just apply. But you can also use kubectl, and you can apply the kubectl the same way that you do with customize. Before we do that, I want to make sure that the manifest.json, that's from .NET Aspire, that's based on those .NET Aspire manifest JSON, that's they creating the manifest files inside the output folder. I have created others here before for the AKS one that I did show for you and for some my local development. To simplify, I'm going to use my previously created. I created this before. That I'm going to show what I changed on the standard default configuration that was created. The first thing, I haven't changed anything. I just mapped the node ports. I changed these to be nodes port, not cluster IP. And I mapped those node ports that I defined when I create the cluster on the cluster configuration file. Each one of those node ports, I have to go and change the service to use those node ports. I have to change the type for node port. The same for API. I change here node port type, and for the web front end, all based on those numbers here for each one of those servers, including OpenTelemetry endpoint as well. And what more I did change? I mapped also an empty volume, and I mounted that inside the app files. Why? Because the application is waiting for that. The application needs app files to function correctly, and I did mount just an empty locally, with just like an empty folder, because just like a caching folder that I'm using on my application to cache the movies. And the idea is to download from like a blob storage and put it like in a caching, and then you don't have to be downloading from the internet all the time. That's the whole idea of the Move Store application. And have a look on the code. And we're going to do some debugging, you're going to understand how that works. But once those small changes are made, we can just deploy. If you go instructions, you can apply from here. You can apply using Aspirate. That's one way you can apply. Or you can just use, let's do this time, the other video I did with Aspirate, but keep in mind that you can do with kubectl. Before that, there is one thing they have to understand. When you degenerate it, you create those Docker images. They are just here on my machine. I have to push this to my Docker Hub. Remember, it's a repository like Azure Container Registry. And those are here on my Docker Hub already, okay? I haven't changed anything. They are there, I can deploy from there. But another way to improve, like if you don't want to download from the internet, you could use just that. You could get kind, get one of those commands, and you can push now your image from your local repository inside the cluster, because the cluster is inside that container. Then if you go to command line, I can push my image, the web front end, and the API, and let's do the API as well. What happened? When you start your application, the images are there. You have a single node in your cluster, and the image will be there already. If you don't want to do that, if you want to do Docker Hub, can just push to Docker Hub, okay? You don't have to do it. If you have these publicly, that's where I'm looking, and they are always going to do that. Let's now deploy. We can do that using that command and get from the folder or the specific folder that I'm using. Is just say kubectl apply, set aside -k, that means customize. And they're going to build the customize and apply on your cluster. And you have to make sure that you are, the kube context will be of your kind cluster. Then it was very quick. And if you go my headlamp, and now we should be a namespace called move store, 10 seconds, container being created. And how can I access the application? Now, if everything is running now, dashboard is all running. Remember the port numbers? Those are the ports where my application here is 8921. Just go in the browser, localhost 891. There you go. Application is working. You can also see 892 movies. That's the API. The API is working. You should be stream/2. You can see that's API is working. It's downloading the movies. Then I have my application working, streaming the video, and also if I select all the video, it'll be loading here. And that's the way that works. Application is copying movies to the storage, to the caching, and next time it'll be faster. And that's the whole idea of the API. And don't forget that we have the 9.3, that's the dashboard. And also now exposing your dashboard. And you don't have to recreate this dashboard all the time. They'll be running here and your application, and the next step is now I have I create the cluster, I deploy my application, create the manifest files, I deploy my application. I want to debug that. How can I debug that? And what I did, I have two Visual Studio open here, Visual Studio Code, one for the API, then when I'm going to debug the API. So let's close these, but let's open some code from the API. That's the minimal API. And I have the code here to stream. I can put a breakpoint there. And for that, I have an extension called MirrorD. I have to install this extension. And MirrorD is a way for you to connect, get the traffic from the application running Kubernetes, and you can steal. There are two ways you can do it. You can mirror or you can steal. And all the configuration is done on that .mirror configuration file here that you can create. And also the extension, you can see at the bottom, you have to enable. Let's enable that extension. And let's select a configuration file. Then I'm going to do the API. I'm going to debug the API first. And the way that works, we want to debug the API. Then let's get the name of these pods within the name of the pod. Okay. The extension can ask you when you start the debug. But the way that I like is I can just put this name here, and then that goes straight to that. Got the name from here. And the configuration saying still. The other way, you could do mirror. Okay. Mirror means they're not going to change every time the traffic can. They're just going to duplicate the call and send to you, and you can debug, or you can completely steal the traffic and process locally on your debug instance. You choose how you want to do that. And for that to be able, they're going to create a pod inside your cluster, you call agent, and I'm defining the namespace, the same namespace of the application that I want to create this agent inside your cluster. Then let's just start the debugger with the MirrorD enabled. They're going to start your debug. And you're going to see that a new pod will be created here. There you go, MirrorD agent being created to manage the redirection of your traffic for you. If that's running, the debugger now is running. How that works? You can just go for your code, go for your API code, API service program. Let's put a breakpoint here when you call the API for the stream. The stream API here. We could do from here. You can do from the application. When I click and I ask, you can see the breakpoint be hitting. There you go. Metrics, that's the one that I ask. And now the movie is here. And if I click here, because they're not going to download the whole movie at once, they're going to hit again the breakpoint. That's what it calls. Still, they're waiting for us to click. You can even put a breakpoint here and stop. And you are debugging here. Another question people ask a lot, can I debug more than one? Yes, I could debug the front end at the same time here. And the nice thing is, if you change this to for the configuration to be, if you change to be mirror, we're not breaking anything. If there is API, there is another development doing debugging in parallel, you both can work with mirror without breaking each other. That's a nice way. I'm doing still here, but you can do mirror. Another way you can do both at the same time. Let me enable this second instance, and let's select the web configuration. I also need the pod name for the front end. That's the way that I'm selecting. Let's get the pod name for the front end. And if you delete this whole path here, they're going to ask you when you start the debugger. It's another way, probably a better way to do it as well. And I have this, I can just go for the debug, I can select web, and I can run. The odd one's still there. Remove the breakpoint. I'm going to start the second one. There's another mirror-d agent for the front end being created 3 seconds ago. It's already running now because the first time the image has been downloaded. And now we have both ones being debugged. How can I debug a front-end application? Let's get, when you click the image, they get in the move ID. And go, when I click here, there I go. The front end be heated of 2, and now I'm debugging both. And even better, I can put a breakpoint back on the API. And now when you hit again, they're going to hit the front end, then hit the back end, and it is debugging the whole thing. How that sounds? Sounds good? That's how debugging with mirror-d works. If you want to learn more about those tools that I'm talking about here, I talk about Aspirate, I talk about kind clusters, how to create kind clusters on WSL2, headlamp, also mirror-d, a nice way to do debugging on Kubernetes. They have a paid license, so you can go for the open source project, mirror-d. And nice that documentation says here, it works with open source and with other versions. And I can see most of the features work with the open source version. Only some advanced features that doesn't work. You can see open source, that's the version that those features are available. And a few configurations that they can have that's so flexible. It's very flexible to manage DNS, to manage outgoing, incoming traffic. Is one of the best products that I know for Kubernetes debugging, in my opinion. That. Thank you so much. Get .NET 9, download .NET 9 today. Also, some reference resource here you can get from NICS about .NET Aspire as well. Thank you so much and see you next time.